But the only part that's important here is how they track the sun, right? They literally draw an azimuthal grid around the observer and then track it in varying degrees of longitude and then track it how it rises. See how it's a perfect circle around the observer? This is what drives programs like SunCalc and how they get the sun shadows. Literally, it's by the observer all over the map. You see how it's working? And the sun declination changes south of the equator versus north of the equator. It's still tracked in a semicircle above the observer. I also should have said that all the sources for these videos are in the event description. I linked them up there, I think. Mostly everything I used for this. How are we doing so far? Anyone have any questions? Chilling?
Oh, I have many questions.
Earth is life. Chill out, man. We already did the global version.
I have a picture of anti-corpuscular rays that I was able to take from inside of a plane. The sun was, I was like looking down at the ground. It's exactly what is being described here for the anti-corpuscular rays. Let's see if I can find it.
Right, so it's a phenomenon that exists. People shouldn't be refuting that they're not real. They are exactly as they say they are, right? And they're simply a product of human perspective on a grand scale. The only other comparable grand scale, I would argue, of the sun would be the stars. That's why the same effect applies to specifically those two things in the celestial sky. I think Jeranism had a video called the Personal Atmospheric Dome, which is not a name that I like or familiar with, but the concepts he explained are pretty similar, pretty analogous. The atmospheric compression is densest at the horizon around you and least dense up top at your zenith, and that's why you get, optical phenomenon like supermoon and crazy sunrise moons, and where it appears bigger on the horizon than it does above you.